This is Algebra 1, Lesson 46, and this lesson is about conjunctions. So conjunctions are basically just complicated, a little more complicated inequalities. So we've seen inequalities before. If I show you something like this, you would know that x is greater than 5. And if I show you something like this, x is less than 10. But if I want to communicate that x is both greater than 5 and less than 10, so x is both greater than 5 and less than 10, I can write it as a conjunction, which means I would write x in the middle, and then I would write these two inequalities around it. And this shows me both pieces of information at the same time. It's saying that x is greater than 5 and x is less than 10. Remember, you're always pointing at the smaller number, so it means 5 is smaller than x and x is smaller than 10. So this means that the number x is somewhere in between 5 and 10. So now if I wanted to graph that, let me graph my little number line over here. Draw a line, a number line, with arrows at each end to indicate they go on forever. And somewhere in this number line, I need to have a 5 and a 10. So I'll just put 5 here and I'll put 10 here. And I want to indicate that the solution to this conjunction inequality, the solution is all of the numbers in between 5 and 10. And since there's no line under these inequality symbols, it means that I'm going to leave an open circle because my solution does not include 5 and 10, but instead includes all of the numbers in between 5 and 10. And so in order to show that, I would shade in between 5 and 10. So let's do another example. We're going to graph another conjunction. So here on the bottom, I'm going to draw a number line and graph the solution to -2 is less than x is less than or equal to 4. So this is another conjunction, and x is in the middle. So go ahead and draw your number line. And take a moment to graph the solution. You can pause the video and check your answer in just a minute. So similar to the last example, we know that x is somewhere in between -2 and +4. So I'm going to graph my line this way. I'm also going to put circles around them. However, this time, the first inequality symbol does not have a line under it, so that means the solution does not include -2. So -2 will be left with an open circle. The second one does have a line under it, so that means that 4 is included in the solution. So I'm going to shade in the 4 bubble, and then I can go ahead and shade everything in between to indicate that my solution is everything, every number in between here, including +4. Let's do another example. This time, I'm going to write a conjunction. That describes a graph. So first I'll draw the graph for you, and then I want you to think about what the graph is telling us, what conjunction can describe this graph. So I've got -10 and I've got 0. The circle at -10 is going to be shaded, and the circle at 0 is not shaded, and then everything in between here is shaded. So what conjunction describes this graph? Take a moment to think about it. The conjunction that describes this graph is going to, of course, have x in the middle to indicate that x is in between two things, and these symbols will both go this way. However, one of these symbols is going to be underlined and one won't. We know that -10 is the smaller number and 0 is the larger number. And since -10 is bubbled in here, I know that -10 is included in my solutions. So I can underline that first inequality symbol, which makes it -10 is less than or equal to x, and then x is less than 0. Let's do maybe one or two more examples. So the next thing I want you to do is I want you to graph this conjunction. Graph the solution using a number line. -5 is less than x is less than or equal to +5. So go ahead, take a minute and graph that. And then two more quick examples. Graph the solution to this conjunction. -7 is less than x is less than -2. Graph that on a number line. And then finally, I'm going to draw a graph and I want you to write a conjunction that describes it. So write the conjunction that describes this graph.